So some circuit based problems, and here find current through each component. So I have replaced all the resistors with some component, bulbs and fan. So anyway, we are interested in resistance, their resistance only. And uh, rate of electric energy consumption, which is power actually. Electric energy has been written here, but rate of energy, and rate of electric energy consumption means power. Power is energy by time, rate of energy dissipation or energy consumption. So how are we going to do this? First, we have to solve this circuit, and first and foremost we'll uh, just mark each one of them. Now we know both of them are in parallel combination, so R1 and R2 are in parallel combination, so 1 upon R12 is equal to 1 upon 15 plus 1 upon 30. In the same way, R3, R4 and R5 are also in parallel, so 1 upon R3, 4, 5 is equal to 1 upon 25 plus 1 upon 25 plus 1 upon 25. Later on I will tell you some shortcuts for these parallel combination, because in some of the parallel combination you can sum off, you can um, do it by a trick which is totally accepted one. It is not a fluke kind of thing. So now see, here LCM is 30, 2 plus 1, 3 upon 30, which is 1 upon 10. So R12 is 10 ohm. And here LCM is 25, 3 by 25. So R345 is 25 by 3 ohm. We can convert it into decimal, but not required. And finally, R12 and R345 are in series. So R12 3 4 5 is equal to sum of R12 plus sum of R3 4 5, which is 10 plus 25 by 3. We have to divide it. It will be 8.3. So I'm instead of this I'm directly writing 8.3 here. It will be 8.333 non-terminating, but we'll take it up to first decimal place only. So it is 18.3 ohm. Okay, now what? Current through each. We have to find current through each component. So for that, what we will do, we'll find first, we will find current through each, current through the entire circuit. So current through entire circuit, how are we going to do that? V equal to IR, V 1, 2, 3, 4, 5 for entire circuit, I 1, 2, 3, 4, 5 for entire circuit, and R 1, 2, 3, 4, 5. This won't work, I guess. So we have to use that fractional form. Otherwise, it will be worst. So horrible it will be. So it is 25 by 3. So it is 55 by 3. And we will use it as it is. Okay. V is 120, I is I we don't know, I 1 2 3 4 5. You can just write I, but 1 2 3 4 5 is giving us an information that it is for the entire combination, because we have to find I1 through R1, I2 through R2, and so on. So these subscripts help us to distinguish between through which current is flow. We are considering which current. Okay, R 1 2 3 4 5 is 55 by 3, so I 1 2 3 4 5 is equal to 360 divided by 55. We can simplify it. I'm leaving it as it is. I have designed this question, so uh, it is getting a bit complicated as far as calculation is concerned. Now we will find potential difference across this combination. How are we going to do that? For that, oh god, for that, all right, for that we will find potential difference across combination of 1 and 2. This 120 is solely not given to this or each one of it. No, actually it will be divided and then it will be consumed by these components. But what will be the potential difference across this will be the same across this, will be the same across the combination. Whatever be the potential difference across this will be the same across this, will be the same across this, will be the same across this combination. So what are we going to do? We are finding the potential difference across 1 2. V12 is equal to I12 R12. Do we know I12? I12 means whatever the current leaving from here will go here, and the combination of it will receive that current. So whatever with this I12 3 4 5 for entire circuit will be the same as I12 that is passing through the combination of 1 and 2. Maybe 1 is getting more current, 2 is getting lesser current, but the sum of them is the same that has been delivered by the cell, that is I1 2 3 4 5, and the same is there 3 4 5, I 3 4 5. So these symbols tells you the I1 2 3 4 5 means the current that emits from here, and I12 means the current which is passing through this part, I345 this entire path. So I12 is same as I12345, that is 72 by 11. So multiply by R12, we have already calculated, it is 10, so it will be 720 by 11 volt. Why we have done it? Because in parallel potential difference remains same, so this is same as V1 is same as V2. V equal to IR again, V is 72 by 11 equal to I1, which is our objective to find. R1 we know 15, so I1 will be 720 divided by 11 multiplied by 15, 5 threes or or will it be yeah, it is getting cancelled by 15. This much current is flowing through first. So V2 you can find of your own, I2 R2, V2 is again this, R2 you can find. And same thing we can do for this part. Okay, now you can see in second part V sorry V345 is equal to I345 R345. So V345 we want, I345 is same as I1234 is same as I12. That is 72 by 11. And R345 is 25 by 3. So it will be 24 will cancel, multiply by 25 divided by 11. So it is getting tougher and tougher. 600 by 11 volt. Okay, here it is, V345. And in parallel, voltage remains same. So this is same V3, V4 and V5. And you can see V equal to IR. All the resistors have same resistance. All the lamps have same resistance. It means current will be divided equally. See, sometimes we say that in parallel combination current is different, but it is conditional statement. If resistances are same, then current flowing through them will also be same. So here if we could find current through 3, so V3 is again 600 by 11 divided by R3 is 25, so it will be 24 by 11 ampere. And how are we going to find power consumption, rate of power electric energy consumption, that is power? So one of it I'm going to do for you, because it is in front of me, I'm doing it. For P3, power across 3, that will be equal to, see, for power we have different formulae. We have VI, we have I square R, we have V square by R. In fact, we have energy by time. So here we have current and resistance both, so why don't we go for this formula? I square, oh, it is getting more challenging for me. R3 is 25, so it will be watt. I am leaving it here, but if you solve it, then try to divide it also and find the answer up to first decimal place. Apart from this, just remember while solving simplifying the circuits, few things you need to be just keep in your mind, just see the pattern. If two resistors are in parallel, or three are in parallel, or four are in parallel, then their resultant is x by 2, x by 3, x by 4, and so on. It means if there are number of resistors of same value and they get connected into in parallel combination, you can directly write this. Means if there is a question 10 ohm, 10 ohm, then parallel combination, directly you can write 10 by 2, 5 ohm. Let's get back to this question where we have these resistors. You can directly write it to 345 is equal to 25 by 3. So just keep this in your mind and you can use it in other questions. Okay, some other tricky questions. This is quite easy, but okay. Let us suppose their value is x, or in fact I'm doing it, bringing some complication here, r up to n. Also another question up to n. And if you are asked to find their resultant, first thing you need to understand, they have given this symbol r. So in your expression you can't use the symbol r. So rs, series combination, or r prime, or r net, or r 1 to up to n. Any of the symbol you can use, and that's all. R plus r up to n, that will be nr. Let me explain you. If there were 2 resistors, then r plus r 2r, 3, then r plus r 3r, 4, then 4r. If there are n, then nr is the answer. Now here 1 upon r p parallel, or any of the symbol you can choose from here. 1 upon r plus 1 upon r up to n. It means r 1 plus 1 plus 1 up to n. So rp is r by n. It was so easy. But now I'm bringing some complication here. But this time I'm not going to use the symbol r. I'm using some other symbol. If its resistance is 1 by x, automatically it is 1 by x. Such type of question can be asked in numerical problem also, if they can give 1 by 2, 1 by 3, 1 by 10, 1 by 100, and any value can be, see, 1 by 2, or if they can give 0.5, we can accept this, but why don't we accept 1 by 2? So in the exam such type of values can come, or this type of question might come up to n. Then what are we going to do? The worst thing will happen if such values will be given in parallel combination. Okay, so in series combination it will be r equal to 1 by x plus 1 by x up to so on. So it will be, that's all. This is the answer for series combination. We have to just add them all. But in parallel, 1 upon r is equal to 1 upon x. Be careful about this. Already the value is 1 upon plus 1 upon x up to n. Remember, this will be x plus x up to n. How easy it is. But the thing is, it is nx. But 1 upon r is nx. So r will be 1 upon nx. So that was also an amazing question. Finally, a complicated one, which is really going to be a challenging problem. Mm, it is a really challenging problem. We have to find, okay, I will give some values here, 1 ohm, 1 ohm, 1 ohm, 1 ohm, and that is being repeated over and over again. Okay, so in such problem, how to solve? Uh, you have to find equivalent resistance. So you can see each time uh, this unit oh sorry, not this unit, this unit has been repeated. So if we want to find resistance of entire this, so we'll assume that resistance of we'll assume that R equivalent is equal to X. Means resistance of this entire unit is X. But as it is going to infinity, so any of the similar portion can also be considered as the value as the resistors of the value that of its equivalent value. So I am replacing this circuit with this circuit. Now this is our circuit. Actually, same unit has been repeated, so we have removed one unit, and for rest of the unit we have assumed that its resistance is X. So if this entire value is X, so also this value is also X. Now this is R1, this is R2, this is R3, this is R4, out of which R2, R3, R4 are in series. R2, R3, R4 are in series. So R2, 3, 4 is equal to R2, 1, X, 1, 2x, 2 plus x. And then this combination is in parallel with R1. R1, R2, 3, 4 are in parallel. So 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2, 3, 4. Okay. R equivalent we know, we already assumed it is x. R1 is 1. R2 is 2 plus x. Now this is going to be a quadratic equation. So we'll take it this side, 1 by x minus 1 by 2 plus x equal to 1, x 2 plus x, 2 plus x minus x equal to 1. So finally it will be x square plus 2x minus 2 equal to 0. Isn't it? Yeah, of course. And now apply quadratic formula or Sridharacharya formula. Minus b plus minus root b square minus 4ac upon 2a. So x is equal to minus b, that is minus 2, plus minus root of b square means 4, minus 4ac means 4 to the 8, minus minus plus, divided by 2. So we will not entertain negative sign, that is this negative sign. So x will be, x is our answer, our equivalent. So that will be minus 2 plus root 12. Root 12 means 2 root 3 divided by 2, that is minus 1 plus root 3 or root 3 minus 1, and root 3 we know 1.73. So answer will be 1.73 minus 1, that is 0.73 ohm. Mind-blowing question, but that was a nice question. And see the concept used here. That's all.